Okay, this is going to be an overview of the SolidWorks Professional Certification Practice Test. We're going to be making this purple block. And first, let's discuss what the best course of action for actually making this part is. I'm going to start with the base right here. It's going to be in this view. And then I'm going to make this pop out with the hole, and then these ribs, and then this cutout, and then these pipes. And you'll see in a bit why I do that in this specific order. So first, let's start and make this base. So I'm going to start with a rectangle. Doesn't really matter what size, but first important thing is to use global variables. So to do that, you're going to type in equals, then quotes around a letter. Right now that's going to be A, because that is what the question gives me in terms of variables. So then when I first create this variable, it's going to pop up as this little globe with an asterisk by it. I'm going to click that, and that'll bring me to what I want A to be. I want A to be 213. So now that I have that, I'm just going to make sure I input all of the variables that the question gives me. So the next one is B, and that's equal to 200. And then C, 170. D is 130, and E is 21. And I also have to make sure I type in X and Y, because those will also be important. And that's equal to A, so you gotta make sure you put the quotes around the A there, divided by 3, and then Y is E divided by 3 plus 10. Okay, now that we've got all that done, we can make this length dimension as B. So I'm going to just type in equals, quotes around the B, and that'll update to 200. Now you want to make sure when you type in your variables, they show up with this red sigma in front of them. If not, you probably didn't use quotes or something else went wrong, so just go back and redo that. Because if you don't, when you try to dimension those later, they will not update. SolidWorks will not treat them as an actual global variable. It'll just be a one-time value. So let's go, and I know this base has rounded corners and they have a radius of 10, so I'm going to use this sketch fillet tool, and I'm going to click each corner, and the preset is already 10 millimeters, so I don't need to worry about that. Gotta click once, it'll update those fillets, and there we go, I'm out of the tool. Now I'm going to extrude this to a height of 25 millimeters. And then next thing I'm going to do is this pop out. So I'm going to create a new sketch, useful keyboard shortcut for getting to the view cube. Instead of going up here to click this button, you can just click the space bar. So I'm just going to do that. And I'm just going to create 2 line segments down here, and then I'll dimension them from the edge, both as 60. And then I'm going to make a sketch fillet. This radius is not 10. In this view it shows the radius is 15, so we gotta make sure we update that. And then I'm going to extrude this again. SolidWorks is gonna come up with this question: do I want to close sketch with model edges? And you can see by this yellow arrow, it's pointing towards the inside of what I want to extrude. So I'm gonna say yes, and then it should come up as a extrudable feature or extrudable surface. Now, I know the height of this is 35 of the pop out and the base, and just the base is 25, so I know in total the pop out is only going to be 10 millimeters tall. And now I'm going to make this hole. So I'm going to come up here to Hole Wizard, and I'm going to go down to the question and look at the presets and it gives me. So I know it's going to be asymmetric, and the default for that hole is already the hex bolt, the ANSI, blah blah blah. So we're good on that, and I already made this part before, so the preset is going to be M8. Make sure the fit is closed. Most of the time, SolidWorks will come up with this near side countersink, which will give you some special features you can use with the hole, but I don't want that because that's not part of this F variable. So, and if you don't see these presets here, you can just click on close or show custom sizing underneath fit, and it's just going to be in the same order as what the question gives me. So 15, 30, and 10. And I also need to make sure I put this hole where I want it. So I'm going to click on this face and just put it wherever I want. And then come back and dimension this as 30 millimeters from each edge. And I should just be able to click OK. And there we go. There's my hole. Now I'm going to make a new sketch and make this ribbing right here. So going off of this sketch right here, let's get in a better view orientation. I'm just gonna sketch out this feature. So I know that this line is equal to C away from that edge. Same thing with this edge, equal to C. I also know these are 80 millimeters long, and E there as well. Now I could have done an equal length relation there, but it was less time to just dimension it. So I'm going to make this arc, and it won't show up as fully constrained. It'll still be in blue because this center point is going to be able to move, and I don't want that. So let's add this relation. Oops, let's get rid of that point, I think. Nope. Oh, it was the arc. There we go. Oh, hold on. Let's try that again. Make this point and that line coincident, and now it should be fully constrained. There we go. Now I'm going to use this tool. It's called Offset Entities, and pretty useful if you don't want to have to go back and trace everything if it's just a little bit away from wherever your original lines are. So I know the width of this is 15, the preset is 10, but I need to go back and hit 15, and then I can just click on the side I want it. You see this little arrow here? I want it on the inside of this line, the bottom right, so I'm going to click there, and there we go. Now I'm going to extrude this, and sometimes with thin features SolidWorks will automatically turn on the thin feature, but I don't want that. I want this line, so I'm gonna go down to selected contours, click on that, come up with this blue box, and then I can click on where I want the ribs to be, which is inside these two line segments. And then once I do that, once I select a contour, a region, I can unclick thin feature, which will make sure the only thing I'm extruding is actually what I want to extrude. Now I know the height of this extrusion is going to be 95 millimeters from the base. The base is already 25 millimeters tall, and we're extruding off of the base, not from the very bottom. So we know that this has to be 70 millimeters tall. Now the next thing I'm going to do is create this cutout right here, and I'm going to use that same tool. I'm going to start a new sketch on this face and use this same tool, offset entities, and I'm going to click all the lines I want for this cutout, and I'm going to make sure the width is 9 millimeters, and should be good. Now I'm going to go back and use this sketch fillet tool again to round these corners, which have a radius of 10 millimeters. It's set to 15, so let's change it back to 10, and there we go. Now we can extrude cut this. It's going to cut too far because it remembers I just extruded this ribbing 70 millimeters. So I know after I make this cut, I want this bottom layer to be 5 millimeters in height. So I can either just do the simple math of 25 minus 5, but for practice, let's do offset from surface, which is good if you know, your extrusion height may be changing with one of the variables, and we want that to be offset from that surface by 5 millimeters, which is that height right there. Doesn't really matter in the grand scheme of things, but just for practice, we want to use as many different varieties as possible. Excuse me. Okay, now let's make these pipes, these hollow cylinders. First, I'm going to make this left one, and to save myself the time from having to constrain this circle 7.5 millimeters away from this line, I can just hover over the top of this rib, and it'll give me this center point, which I can click on, and then I know that circle will be constrained to that, regardless of what you know, global variables I change. So I know the diameter of this left one is equal to x, and I can extrude this I need to make sure I include this overhang 10 millimeters. So for the first direction, let's type in 10, and then let's click on direction 2 and make the distance equal to D, except for D, we're starting from this plane, so we need to make sure that this length from the where I started the sketch to the end, the other end of the pipe is D minus 10. And there's just make sure you put a space in between the minus and the 10. If not, SolidWorks will read that as D minus 1, and you do not want that. So let's click OK. That looks pretty good. And let's do that on the other side. I can't really pattern this because the radiuses are different, but I'm sure you could figure it out somehow. This is just the way I'm doing it. So this is Y, and I'm going to extrude that in the same way, 10 millimeters one way, and then D minus 10 in the space the other way. And I did it this way because I wanted to cut through with the hole both the rib and the cylinder, so that I wouldn't do the rib last or something and then have extra material in the hole. That would not be fun. So far, there is not a way I have figured out to use dimensions in the hole wizard, so right now it's just going to be easier and probably just as fast to just extrude cut it because it's not that complicated of a dimension or a hole. And the radius of that is E, and we're just gonna go to features, extruded cut, and make sure you can use this drop down menu to select any one of these. You can do through all, which will give you all the way to the end of the base, or you could just do up to next, which is just going to look nicer. Doesn't really matter. But moving on, let's make this second hole. And I don't want to come back and have to add relations, so I'm making sure I have the center point of the circle and the center point of what I already made. If that's not showing up, what I just did is hovered over the edge of the feature, and then usually the these points around here will show up. Click on the center point, mention this as E. Nope, E, not D. There we go. And we're gonna extrude cut that as well, and then we're gonna do to next as well. Now, what you might see here, but not understand fully, what looks like two concentric circles. It's a little hard to see in the detail, but this is actually a chamfer. It is not a fillet, so it's not curved. So what this means down here is there are 4 of them, one on each side of the pipes. There is a radius of 45 degrees, and the chamfer is offset from the cut by 2 millimeters. So its radius is 2 millimeters larger than this edge right here. So the chamfer feature is under the fillet button. So hit fillet, the drop down menu, and hit chamfer. Now I could individually select these edges, but SolidWorks will recognize if you just click the whole hole, and it'll do both edges for you. And since I did this part already, it already has this presets of 2 millimeters away from the original edge and 45 degrees. So this is the end of question 1. Let's make sure before we go any farther, apply the material. The material is alloy steel. Let's apply that and then close the window, and we should, there we go. The answer, although it is really hard to see, is what we got here, 1,000 or 14,207.34 grams. That's spot on. So question 2 and 3 from here should not be that much more difficult. What we can do is right click on equations, hit manage equations, and go back and change these values. So for question 2, A is 225, B is 210, C C is 176, 137, and 39. And X and Y don't change. So once that updates, we can go right back to mass properties, and we should get 16,490.48. We're a little off. I'm not sure this answer is completely correct because every time I've done this I've got 0.48, but we are definitely in the limit of the 1% tolerance, so let's move on again. I would suggest in between questions, making sure you save each individual part or each individual version as a new file, just so that if you realize you messed something up, you can go back and change that. So I'm not going to save just because that's going to take a lot of time, but we can move on to question 3, which is just changing the parameters again. What's there? Okay, now let's go back to mass properties, and we got 15,100 0.46 grams, 0.1 off from the answer. So I think SolidWorks usually, maybe it's just I designed it a little bit off, but SolidWorks usually gives a plus or minus 0.01 gram error in what I found, so it doesn't matter if we're completely spot on.